CCSP exam practice questions. Domain 1. Cloud concepts, architecture, and design. Part 5. Question 1. An organization is implementing a new cloud-based manufacturing system that utilizes sensors to monitor production processes in real time. Which emerging technology poses the greatest security concern in this scenario? A. The use of edge computing devices may introduce vulnerabilities due to limited processing power for security controls. B. The implementation of quantum computing could compromise the encryption of sensor data. C. Industrial IoT devices often run outdated software versions, and manufacturers may advise against updates. D. The containerization platform might not properly isolate manufacturing control systems. Correct answer, C. Explanation. In industrial IoT environments, one of the most significant security challenges is that manufacturers often advise against updating control systems and sensor devices due to stability requirements. This creates a serious security vulnerability, as these devices may run outdated software versions with known vulnerabilities. While the other options present valid concerns, the inability to patch and update IoT devices in industrial settings poses the greatest immediate security risk, as it leaves systems exposed to known vulnerabilities that cannot be easily remediated. Question 2. A cloud security architect is evaluating the implementation of artificial intelligence for security operations. Which type of analytics would be most appropriate for predicting potential security incidents? A. Prescriptive analytics to optimize security control configurations. B. Predictive analytics to identify patterns that may indicate future threats. C. Descriptive analytics to understand current security posture. D. Quantum analytics to process security event data. Correct answer, B. Explanation. Predictive analytics is specifically designed to use existing data to predict future events. In security operations, this type of analytics can analyze historical security data and patterns to identify potential future security incidents before they occur. Descriptive analytics only describes current conditions, while prescriptive analytics focuses on optimizing decisions. Quantum analytics is not a real type of analytics. Predictive analytics is particularly valuable for security operations as it enables proactive threat mitigation rather than reactive incident response. Question 3. A financial services company is developing a new cloud-based solution for tracking international transactions. Which emerging technology would best ensure transaction integrity and transparency? A. Edge computing to process transactions at network endpoints. B. Machine learning to categorize transaction patterns. C. Blockchain to create an immutable distributed ledger. D. Confidential computing to protect data in memory. Correct answer, C. Explanation. Blockchain technology is specifically designed to create a distributed, immutable ledger that prevents tampering with transaction records. This makes it ideal for tracking financial transactions, as it provides transparency, prevents unauthorized modifications, and maintains a permanent record of all transactions. While other technologies listed have their benefits, none provide the same level of transaction integrity and transparency as blockchain. The distributed nature of blockchain also ensures that no single point of failure exists in the transaction record system. Question 4. A DevSecOps team is implementing infrastructure as code for cloud deployments. Which approach provides the most effective way to maintain security consistency? A. Manually configure security settings after server deployment. B. Create immutable servers with automated security configurations. C. Allow developers to modify production servers directly. D. Deploy servers without baseline security configurations. Correct answer, B. Explanation. Creating immutable servers with automated security configurations through infrastructure as code is the most effective approach for maintaining security consistency in a DevSecOps environment. This approach ensures that all servers are deployed with identical security configurations, eliminates human error in configuration, and prevents unauthorized changes to running servers. If changes are needed, new servers are deployed with updated configurations rather than modifying existing servers, maintaining consistency and providing a clear audit trail of changes. Question 5. An organization is processing sensitive data in a cloud environment and needs to ensure protection throughout the entire computing process. Which technology should they implement? A. Edge computing to process data at network endpoints. B. Container isolation to separate processing environments. C. Blockchain to create an immutable audit trail. D. Confidential computing with trusted execution environments. Correct answer, D. Explanation: confidential computing with trusted execution environments, TEEs, is specifically designed to protect data throughout the entire computing process, at rest, in transit, and in use. TEEs provide protection for data writ while it is being processed in memory, which is a crucial security gap in traditional computing environments. While other technologies offer various security benefits, only confidential computing provides comprehensive protection throughout the entire computing process, including the previously vulnerable in-use phase. Question 6. A manufacturing company is implementing IoT sensors in their production facility that connects to cloud services. Which security consideration is most critical? A. Ensuring quantum encryption for all sensor communications. B. Implementing blockchain for sensor data storage. C. Verifying that device firmware can be updated to address vulnerabilities. D. Using edge computing for all sensor data processing. Correct answer, C. Explanation: the ability to update device firmware is the most critical security consideration for IoT devices in a manufacturing environment. As new vulnerabilities are discovered, the ability to patch and update firmware is essential for maintaining security. The other options, while potentially beneficial, do not address the fundamental security requirement of being able to remediate vulnerabilities through updates. Without the ability to update firmware, IoT devices remain vulnerable to known security issues, potentially compromising the entire production environment. Question 7. A cloud service provider is developing a solution that involves processing large amounts of sensor data from remote locations with limited network bandwidth. Which approach would best address this scenario? A. Implement blockchain to distribute data processing. B. Deploy quantum computing solutions for faster processing. C. Use edge computing to process data near the source. D. Utilize container orchestration for data processing. Correct answer, C. Explanation: edge computing is specifically designed to address scenarios where large amounts of data need to be processed from remote locations with limited network bandwidth. By processing data near its source, edge computing reduces the amount of data that needs to be transmitted to central cloud locations. This approach is particularly effective for sensor networks and IoT devices where network bandwidth is constrained. While other technologies offer various benefits, none directly addresses the challenge of processing large amounts of data with limited network bandwidth as effectively as edge computing. Question 8. An organization is implementing machine learning for cloud security monitoring. Which type of analytics would be most appropriate for determining the optimal allocation of security resources? A. Descriptive analytics to catalog current security incidents. B. Predictive analytics to forecast future attacks. C. Prescriptive analytics to optimize security resource deployment. D. Quantum analytics to process security logs. Correct answer, C. Explanation: prescriptive analytics is the most appropriate choice for determining optimal resource allocation because it is designed to recommend actions by simulating different scenarios and their outcomes. Unlike descriptive analytics, which only describes current state, or predictive analytics, which forecasts future events, Prescriptive analytics specifically focuses on determining the best course of action among various possibilities. In this scenario, it can help determine the most effective deployment of security resources by analyzing multiple factors and scenarios to optimize security coverage while minimizing resource waste. Question 9. A development team is implementing a new cloud-native application using containers. Which security consideration is most important? A. Ensuring quantum-resistant encryption for container communications. B. Implementing proper isolation between containers and the host system. C. Using blockchain for container orchestration. D. Deploying edge computing for container management. Correct answer, B. Explanation. Proper isolation between containers and the host system is the most critical security consideration in container deployments. Without proper isolation, containers could potentially access resources or data from other containers or the host system, compromising the entire environment. While other technologies mentioned may provide various benefits, none addresses the fundamental security requirement of maintaining strong boundaries between containerized applications and the underlying system. Container security relies primarily on this isolation to prevent unauthorized access and maintain the integrity of both the containers and the host system. Question 10. In a DevSecOps environment, which approach provides the most effective method for maintaining security when deploying new cloud resources? A. Manual security testing before deployment. B. Security as code with automated testing and deployment. C. Post-deployment security scanning. D. Ad hoc security reviews during development. Correct answer, B. Explanation. Security as code with automated testing and deployment is the most effective method for maintaining security in a DevSecOps environment. This approach integrates security directly into the development and deployment pipeline, ensuring consistent application of security controls and automated testing before deployment. Manual testing, post-deployment scanning, and ad hoc reviews are less effective as they can be inconsistent, may miss critical issues, and don't scale well in a fast-paced DevSecOps environment. Automation through security as code ensures that security controls are consistently applied and tested throughout the deployment process. Question 11. A company is implementing a fog computing architecture for their IoT devices. What is the primary security advantage of this approach? A. It eliminates the need for encryption. B. It provides quantum-resistant communication. C. It reduces the amount of sensitive data transmitted to the cloud. D. It ensures complete isolation of IoT devices. Correct answer, C. Explanation. The primary security advantage of fog computing in IoT architectures is that it reduces the amount of sensitive data transmitted to the cloud by processing data at intermediate nodes closer to the source. This approach improves security by limiting the exposure of sensitive data during transmission and storage in the cloud. While fog computing may provide other benefits, the reduction in data transmission to the cloud represents its most significant security advantage. This is particularly important in IoT environments where devices may collect sensitive information that doesn't all need to be transmitted to central cloud services. Question 12. An organization is developing a cloud-based supply chain management system. Which emerging technology would best ensure product authenticity and traceability? A. Edge computing for real-time tracking. B. Machine learning for pattern recognition. C. Blockchain for immutable supply chain records. D. Quantum computing for complex calculations. Correct answer, C. Explanation. Blockchain technology is the best choice for ensuring product authenticity and traceability in a supply chain management system due to its ability to create an immutable, distributed ledger of transactions. This ensures that once recorded, supply chain data cannot be altered, providing a reliable audit trail of product movement and handling. While edge computing could help with real-time tracking and machine learning could identify patterns, neither provides the same level of guaranteed authenticity and immutability as blockchain. The distributed nature of blockchain also ensures that all supply chain participants have access to the same verified information, improving transparency and trust throughout the supply chain.